Okay, okay. You see the screen now?
Yes, uncle, now is good.
Okay, fourth sum. So which set of numbers do mean, median, mode all have the same values? Okay. Let us do that sum. If we had finished it by now, we should have been in probability. You guys are doing very slow. You are making the whole thing slow. See, I understand school has started. Okay, that school thing you do that no afterwards. You finish this thing first, because here we are trying to get 100 out of 100 and make things very easy. So you give priority to this tuition class. You understand? Only one class. Give priority to this class and do your school homework afterwards. அதில் நீங்கள் வந்து if you take lesser marks, it's okay. But if you do this correctly, you are going to guarantee yourself 100 out of 100 in your 9th standard exam. So understand that and do that. Okay. Plus one more thing. In the school, they will keep skipping this portion, that portion, and all of that. I am not skipping anything, so that you will understand. Okay, I am taking 10th standard tuitions. Guys, are you listening?
Yes, uncle.
Okay, I'm taking 10th standard tuitions. Because in 9th standard, they didn't handle statistics, they didn't handle this, that, and all that. They skipped, and you were all very happy because they skipped the portion and portion was less. But when you come to 10th standard, you don't know anything about how to do the sums, because 9th standard, you didn't have the basics. Okay, so you will get caught. Don't think the teacher who's doing away with all the portions and giving reduced portion is a nice teacher. That teacher is spoiling your future. You understand? If the government is doing the reduced portion, the government is spoiling your future by doing reduced portion. It's not helping you. You're thinking it's a very nice thing, it's very happy because you have little to study. Okay, you will know nothing. By the time you come to +1, you will know nothing at all. You will score very badly in your +1 and +2. This corona will not be here forever. In 1 year or 2 years, corona will vanish. After that, what will you do? Where will you go for your maths? Where will you go for your science? Okay, so study everything. Because they are giving reduced portion, you don't reduce it. Study everything. Okay, let us do exercise 8.4 fourth sum. Mean, median, and mode you have to find out. Okay, what is a mode first? Look at the second fellow. Look at the second fellow. Mode is 1, 3, 3, 3, 5. Okay, 3, 3, 3. This is mode is equal to 3. Okay, now calculate median. 1 plus 3 plus 3 plus 3 plus 5. 5 plus 3, 8. 8 plus 3, 11. 11 plus 3, 14. 14 plus 1, 15 by 3. Again,
15 by 5.
By 5. Okay, by 5. That is equal to 3. Very good, very good. So median also 3.
Mean, uncle.
3. Huh?
Mean is 3, uncle.
This is median. Mean is 3. Okay, now you do the median. 1, 3, 3, 3, 5. Okay, like that. Out of 5, n plus 1 by 2th value. So 6 by 2 is equal to third value. Third value is 3. Again, so third value is also 3. That is also median. So mode, mean, median, all three are same for number 2. Okay, that is 1/4 sum. Okay, now fifth sum. I finished classwork yesterday. Sixth sum homework. What did you do? The mean of A, B, C, D, E. A plus B plus C plus D plus E is 28. Okay, so A plus B plus C plus D plus E is equal to 28 into 5. How much 28 into 5? 40, 2 tens are 2 5s are 10, 14, 140. 140. Okay, A plus B plus C plus D plus E is equal to 130. So 140. Okay, if the mean of A plus C and E is 24, A plus C plus E plus B plus D is equal to 140. Now he's telling if the mean of A plus C plus E, no, that is how much? 24. Okay, then A plus C plus E is equal to 24 into 3. You bring the 3 this side, and that is equal to 72. Okay, so a plus c plus e is equal to 72. That means substitute the 72 here. Okay, I mean substitute the 72 here. 72 plus b plus d is equal to 140. Then how much is b plus d? 140 minus 72, that is equal to 68. B plus d is equal to 68. What is he asking? The mean of b and d. B plus d by 2 is asking that. Okay, that is equal to 68 by 2. That is equal to 34. Where is 34? Answer number 4 is correct. Okay, you
Okay,
got
uncle.
it?
Okay, uncle.
Hello. Arpana, no sound from you. How are you doing? Too much school, huh? You're tired with school.
Today I had online classes, uncle.
Oh, very good then. Better online. Simply going to school, you can enjoy life there with your friends, meet other friends.
Yes, uncle.
Yeah, but in terms of getting the work done, there's a problem. Okay. That is the homework sum which you didn't finish, which we have finished now. 6 sum. 7 sum classwork we already finished. 8 sum now. Let us do 8 sum. The mean of .48 sum. Okay. The mean of 5, 9, 17 and 21 is 13. 1, 2, 3, 4, 5. Okay, that means 5 plus 9 plus x plus 7 plus 21 is equal to 65. Okay, 5 plus 9, how much? How much, guys? Fast, guys.
13.
Oh, come on, yeah.
14, uncle.
14 plus 7.
28.
21, uncle.
What are you doing? For a 9th standard and the simple additions and all that you are suffering from. It's very bad. 21. 21 plus 21.
42, uncle.
So 42 plus x is equal to 65. So x equal to 65 minus 42. 3 to 23, x equal to 23. Okay, what is asking you to find out? X is 23. No, something went wrong here. Wait. 5 plus 9, 14. 14 plus 7, 21. 21 plus
Uncle, it's 17.
17. Okay, this is 17. That means this is 52. This is 13. X equal to 13. Okay, so which one is that? Number 2.
Option 2, uncle.
Answer number 2. So 8th one is solved. Okay, very simple sum. Why you are not able to do this? Why you didn't do this? It's very bad. You should have done this. These are all mental sums. When will you do then? You're not thinking through anything. Calculation itself problem. Okay, what is the last one? 10th sum also homework. 10th sum also you didn't do. Sandhya, very bad, Sandhya. Nothing you did. 10th sum, okay. Mean of a set of numbers is x bar. If each is multiplied by z, the mean is what? If you add k to x bar, then the new mean will be x bar 2 will be new mean will be k plus x bar. If you multiply it, then new mean will be k into x bar 1. Okay. So what is the answer? Third one. That's all. Very simple one you didn't do. You are telling you don't know how to do. What is there to know how to do this? Yeah. You have to use your brain. That's all. Next time you don't tell me you don't know how to do. Don't go to the guide and copy some mindlessly from the guide or from online PDFs. Don't do that. If you do that, then your capacity to learn is gone. The capacity to learn is gone. Okay. Now let us be done with this thing. We are going to a new topic today. New topic is probability. Probability theory is nothing more than common sense, which is reduced to calculation. Okay. Common sense is what? Will it rain tomorrow? What is the chance that it will rain tomorrow? What will you say? You tell me one answer. In
10%.
Chennai, will it rain tomorrow?
10% chance.
Huh?
10% chance.
10% chance only. So you are feeling that it will most probably it won't rain. Very less chance of rain. Okay. Suppose it has been raining in Chennai for last 3-4 days. Then I ask the question, what is the probability it will rain tomorrow? What will you say?
85%.
85%. You understand common sense, that is only thing reduced to calculation. So when you're telling 10%, 85%, that is all common sense, which is reduced to calculation. Okay. Now remember this fellow R von Mises. Okay. He made it possible to build up a strictly mathematical theory of probability based on measure theory. Such an approach emerged gradually in the 20th century under the influence of many authors. Okay. You take an empirical attitude towards probability. We'll see what was the classical attitude to probability and what is the empirical attitude towards probability. Remember these two things. The classical attitude was more a priori, whereas the empirical attitude is a posteriori. What is a priori and a posteriori? You know anything? A priori means before you do anything in the field, before you go and actually take an observation in the field, or survey or do an experiment, mentally itself you calculate and say. In the mind itself you calculate and say prior to the actual experiment being done. Okay, that is a priori. But if you do the other one, it's an empirical approach. What is the empirical approach? Go to the field, do some experiments, get the measurements out of that, and then you find out what is the probability. That is a posteriori method of probability. Okay. The modern method is the empirical method, empirical approach of probability. The classical approach, which was done in the 17th century, 1600s and 1700s, they had the classical approach, which is the a priori approach, not the empirical approach. Okay. We'll see all that. Let us see some real life situations involving some traits of uncertainty. Okay, some life-saving drug they are found out for corona. Now they are administering that drug to a patient. Okay, now the patient is dying. He wants to know whether the drug will work. They'll be happy if the doctor tells that out of 100 patients treated with this corona, anti-corona drug, 80% became well. Okay, so this percentage of success is illustrative of the concept of probability. So how frequently it occurs? So out of 100 times, people who are treated, 80 times people become well, they don't die. Okay, that frequency of occurrence, that is the core issue when you deal with probability. Okay, you have to understand probability means the frequency of the occurrence and versus the frequency of not occurrence. That is only helping us arrive at empirical probability. So you can use this to arrive at conclusions under uncertain conditions. When you cannot say for sure, then you use probability. Most of the situations in life, you are not sure, correct? Tomorrow will it rain or not? We are not sure. Tomorrow will you live or not? We are not sure. Okay. Will they again close the schools and go back to online? Probably they might, or probably they may not. We don't know how much certain we are. We don't know. So most 99.99 situations in life, we don't know with certainty what will happen. So that is why probability is the most important and most practical subject. Okay. Now you should be familiar with playing cards. How many play Rummy or 304 or Declare or any other game, card game? How many of you play? Have you played Rummy?
No.
Nobody's played any card game. Then what you will do when you are getting bored in holidays and all? What you will do? You want to play with daddy? Probably daddy is thinking playing cards is a sin. What to do?
I play cards, uncle.
You play cards. What game you play?
Like rummy, uncle.
Rummy you play, no? Yeah, like that. So then you know about 52 playing cards. It has 4 suits, okay? What is suits? There are cards which with hearts, cards with clubs, then with diamonds or dice and spades. Each having 13 cards, so therefore totally 52 playing cards. Choose one of the suits or cards. Let us say you choose spades. Keep these 13 cards facing downward on the table. Now you shuffle them well. Shuffle means kulugad. You do like tuck, 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 and you don't know which series is there. Shuffle them well and pick up any one card. What is the chance it will be a king? Can you tell me? 13 spade cards you have kept no, this facing downward, not upward. So you don't know what card it is. You faced it downward. Then from that you pull out one card. What is the chance it will be a king? How do you find out? Only with spades, 13 cards. The chance. What is the chance you don't want a king, you want to find a A. See, this is A. This is A card, okay. What is the chance it will be an A card? What is the chance it will be a king card? What? See, how many cards are there?
13.
13.
Total number of cards available, 13. Okay, one king, how many kings possible? Cards that you can pick which your king is how many? Only one card. So the probability is 1 by 13. Okay. So here you have a very easy idea. Possible outcomes, number of possible outcomes by total number of outcomes. All the outcomes. Okay. All the outcomes are 13. You can pick any card, you can pick 13 cards. That card, only one king is there. So 1 by 13 chance that it will be a king. Okay. So the ratio of the favorable cases to the number of the possible cases. All the possible cases versus the cases that are favorable to your event. The event is the picking of a king. That is the event. What is event? The event here is picking a king. Picking a king is the event here. Okay. Total number of all the possible cases are 13 because there are 13 cards. There is only one king like that. Have you seen a dice? Snakes and ladders game, how many people have played?
Yes,
I
uncle.
played, uncle.
You played snakes and ladder. Okay. See, die is a word for singular and dice is for plural, but we will use even for single one die also you'll say a dice only. Okay. A standard dice is a cube which each side having different number on it, ranging from 1 to 6. You know that, right? So this is like that. This side is 5, this side is 3, this side is 6, maybe that side is 1, that side is 4, and this side is 2. Okay, 6 sides it will have, each side will have one number from 1 to 6. If you throw the dice, what is the probability of getting a 5, a 2, or a 7? Can you tell me?
10%, uncle.
Huh?
10 or 5%.
Say that again, ma.
10 or 5%.
No, you should not use percent now. Now you know ratio of the favorable cases to the total number of possible cases. Use the formula and tell me.
3 by 6, uncle?
The favorable cases by number of favorable cases by number of all possible cases. What are all the possibilities? Dice la inna nalla ulum ஒரு தாயம் போட்டா என்ன நம்பர்லாம் உளும்? What are the numbers that can fall? 1 2 3 4 5 6, that's all. Can you have a 7?
No, uncle.
You can't have a 7, only 6 numbers. This is the possible cases. So total number of possible cases is 6. Okay, he's asking what is the chance of getting a 5. How many 5s are there in a dice? Only one side, 1 5 only is there, correct? So 1 by 6 is the possibility of getting a 5. What is the possibility of getting a 2? Again, total number of cases is 6. How many 2s are there? Favorable cases.
Only one, uncle.
Only one. Again, that also 1/6. What is the possibility of getting a 7?
0, uncle.
0 by 6 is 0. Okay, very good. Okay, so you won't get anything. Very good. You understand now. Good, you understand. So let us do some basic ideas now. We will formalize the notions. Okay, please understand one thing. When you do some experiments in science, under the same kind of conditions, you keep on repeating the experiment. If you get almost the same result, such an experiment is called deterministic. Okay, deterministic. For example, the experiment to verify Archimedes principle or verify Ohm's law, all these are deterministic because it will give the same value for resistance every time. In physics, you have studied Ohm's law, right? So same result will come. That is deterministic. The outcome of the experiments can be predicted. Please understand, if you can predict the outcome in advance, then it is called a deterministic experiment. Probability is not for such kind of experiments. Okay? Probability is for the other kind of experiments where the outcomes will be different every time. Okay, even if the experiment is performed under identical condition, the outcome is different every time. For example, okay, you roll a dice. Okay, same, you are playing snakes and ladder in the same room on the same table. Okay, when you throw once, it comes 1. Next time you throw, it comes 3. Next time you go, it comes 5 or 6. Okay, you cannot control it. Every time it is different. Okay, can you predict what will fall? You cannot
No.
predict. You can so that we cannot predict the exact outcome. That is where probability comes in. And these kind of experiments are called random experiments. So throwing a dice is random experiment. Then they go for cricket match and they throw a toss and see who will get heads or tail. If the captain calls head and he gets head, then he will choose what he wants to do, bowl or bat. Okay, so that is also a random experiment. Now, every time you do a random experiment, it is called a trial. And the result of each trial is called an outcome. Okay, for example, the random experiment is tossing a coin. Okay, every time you toss a coin, you are doing a trial. And whatever falls, first time head is falling, that is an outcome. Second time also head is falling, that is another outcome. Third time tail is falling, that is another outcome. Okay, like that. If you toss the coin 4 times, you have done 4 trials. And suppose H came head, tail, like that it came. Then you have 4 outcomes, head, and tail. You understand the difference between experiment, trial, and outcome. Experiment and trial are the same thing. What, guys? Experiment means trial. Okay. Yeah?
Understood, uncle.
I understood. Okay. Now, outcome is the result. You got a head. Throwing the coin is a trial or experiment. You got a head or you got a tail. That is the outcome. Okay. Same way, throwing the dice is an experiment. You got a 6. That is the result or outcome. Okay. That is the difference between trial and outcome. Experiment is throwing the dice. You got a 5. That is the outcome. Okay. So now let us see some of the important terms related to probability. Trial. Rolling a dice and flipping a coin, they are the trials. We saw that. Outcome. When you flip a coin, you get a head or tail, that is called outcome. The result of the trial is the outcome. Now, very important thing you have to learn now. Okay, what is that very important thing? Something called sample point. What is sample point? When you flip the coin, each outcome, suppose you get a T. 4 times you are doing experiment. 4 trials, you get H and T. Each of that is a sample point. One H is a sample point. Another H is a sample point. Third H is a sample point. Fourth T is a sample point. Okay. So each outcome is called a sample point. And then all the outcomes which are possible together is called a sample space. For example, when you flip a coin, what are all the possible outcomes? Total number of all possible outcomes when you flip a coin once.
2.
Either you will get a head or you will get a tail. All right. You should toss a fair coin. See, In Sholay, have you known the movie Sholay? In Sholay, Amitabh Bachchan will have a coin and he will always toss it with Dharmendra. But when after Amitabh died, he will take the coin and see both sides, it will have heads. Okay, that is not a fair coin. What is it not called? It is an unfair coin. So unfair dice, unfair coin, we are not talking about that. We're talking about a fair coin and a fair dice. Okay. So when you flip a correct fair coin, then you will get HRT. They are the two sample points. So, okay. And then the set of all the sample points is a sample space. So sample space S is equal to, always you used S to denote sample point, sample space. Always the set S is equal to denoted the sample space. S is equal to, open the bracket, okay, then H stands for head, T stands for tail. Okay, understood? Okay, that is if you threw only one coin. Okay, now suppose you threw two coins parallelly. There are two fellows standing. Both Arpana and Sandhya are standing with a coin. Both of you are flipping the coins. Okay, so on the ground, what will fall? First time, let us say, both of you, your coins are giving H and H. Arpana also getting H, Sandhya also getting H. Then it is HH. Second time you are throwing, Arpana gets H, Sandhya gets tail. Then it is HT. Third time you are throwing, Sandhya gets H, Arpana gets T. This is TH. Fourth time you are throwing, both of you get tail. Okay, tail and tail. That is TT. These are the four possible of all the outcomes. These are the four possible outcomes. Okay, so the sample set is equal to HH, HT, TH, and TT. Each of this is called a sample point. TT is a sample point. HH is a sample point. TH is a sample point. This entire thing is a sample space. Understood now? No? Very easy to understand. Event. What is event then? If you throw a dice, it shows 4. Okay. Then that 4 number coming is called an outcome, since it is the result of a single trial. In the same experiment, okay, the event of getting an even number. Now you see what is a new thing you are getting. Outcome is a single outcome. Event is defined differently. Event of getting an even number. This is an event. So in the sample space 1, 2, 3, 4, 5, 6 it will have. Throwing a dice, the sample space, all possible outcomes are 1, 2, 3, 4, 5, 6. What is the, this is the, each of this is a sample point. Okay. And so what is the event of getting an even number? So you are not going to throw it once. You are going to throw it once. You are going to flip the dice once. Okay. What are all the possible or favorable outcomes? Favorable outcomes by the all possible outcomes. All possible outcomes, how many are there? Number of favorable outcomes, number of all. All possible outcomes, number is how much?
6, uncle.
6, very good. Favorable outcomes of getting even is 2, 4, 6, even number. Okay. So that is only 1, 2, 3. So that 10 is equal to 3. So 3 divided by 6 is your probability. If you cancel, you will get half. So probability of getting an even number is half or 0.5. You understand? P is equal to 0.5. Like that you should write. For example, random experiment is flipping a coin. Possible outcome head or tail. Sample space is H and T. Subset of S. Subset of the sample space will be H or T. Okay, this subset can be an event. And event is called A. Okay, this event of getting a H. That is a A. Event of getting a T. That is also another event. If you toss a coin, the event of getting even numbers, okay, that is 2, 4, and 6. The event of getting odd numbers, that is 1, 5, and 1, 3, and 5. 1, 3, and 5 is the event of getting odd numbers. Okay, so event A, you should not confuse with outcome. Outcome is a single thing. One sample point is an outcome, but event is defined differently. You understand the difference? It's very important to note. Outcome means you got a 3. Okay, that is an outcome, result that actually came. What is the probability of an event of getting an odd number? Okay, that probability, there are 3 favorable cases. What are the 3 favorable cases? 1, 3, and 5. So 3 favorable cases out of all possible cases is 6, that is equal to half. So the probability is half. The probability of what is half? The probability of the event A of getting odd numbers. Of getting a odd number. Okay, that is outcome was 3 means fine. Outcome was 4 means, oh, it was not a, the event did not occur. Understand? Suppose you threw the dice, you got a 4, then the event did not occur. You understand? Only if 1, 3, or 5 happens, the event occurs. Okay, so you got a result where the event did not occur. That is the difference between event and outcome. Outcome is a single sample point. Event is a subset of the entire sample space. Okay, entire sample space. For example, the collection of all sample points is 1, 2, 3, 4, 5, 6. This is the entire sample space. Okay, a subset of that 1, 3, 5 will be an event. Another subset of that 2, 4, 6, that will be another event. This is event A, probability of getting odd numbers. This is event B, probability of getting even numbers. That is also half. Probability of getting odd numbers, that is also half. Okay. When we select a day in a week, the collection of sample points will be what? How many you will get? Number of days in a week, how much? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So the total sample space size is 7. And the sample space is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You understand?
Yes, uncle.
S is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. N of S is equal to 7. S is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You understand the difference between S and N of S?
Yes, uncle.
Probability is used by calculating N of S and number of the probability of the event divided by number of S. Okay. So suppose getting odd number is 3, and then the total sample space number is 6. Okay, like that. This is the formula. P of A is equal to N of A by N of S. That is the formula. Very simple formula. It's all common sense. Okay, when did we start the class? 5:35. Okay, we have time. This activity and all you can do. I don't want to do. Okay, you do that. Huh? Both of you can do something. See, total number of times the head comes up divided by total number of times the coin is cost. Okay. Number of times tails comes up by total number of times the coin is tossed. Like that, they are doing some experiments. Let us skip to the things. Now, I told you there is a classical approach and there is an empirical approach. There are 2 different approaches. 1700s and 1800s, they used the classical approach. In 20th century, okay, von Mises and all these guys got together and they got the modern approach, which is the empirical approach happening. Classical approach is a priori. Before you go to the field itself, in your mind itself, you make the calculation and tell what will be the probability. How can you do that? See how you are doing that. The chance of an event happening expressed quantitatively is probability. Okay, you can say 15%, 85%. That is also one way of saying probability. The other way of saying probability is instead of 15%, you say 0.15. Instead of 85%, you say 0.85. Then that is probability. All right. For example, an urn. Look at this. The urn na chatti, pana. Okay, inside a pana, there are 4 red balls and 6 blue balls. You choose a ball at random from the urn. Can you predict what it will be? You cannot. Okay, at random you are choosing. What is the probability of choosing a red ball? So random means each one of the 10 balls has the same chance of getting chosen. You should be blindfolded and the balls may be mixed up for a fair experiment. Okay, you should not be able to see inside the urn. So உன்னை சுத்தி ஒரு கண்ணு கட்டிடுவாங்க. அதுக்கப்புறம் நீ கையை விட்டு அதுக்குள்ள இருந்து 4 ரெட் பால் 6 பால்ல இருந்து ஏதோ ஒரு பால் எடுக்கணும். ஓகே, What is the probability that the red ball is chosen? What is the probability?
4/10.
Yeah, 4/10. How did you get that? All possible outcomes. All possible outcomes. Number of all possible outcomes by number of favorable outcomes. So how many favorable outcomes are there? There are only 4 red balls. How many balls are there totally? There are 4. Okay, so 4/10 or 0.4. That is the probability of a red ball. So similarly, what is the probability of blue ball? 6 blue balls are there. Total number of
6/10.
favorable by total number. How much?
6/10.
6/10.
Okay, you got that, no? Now look, one interesting thing. The sum of the probabilities is 1. That's very important. No other outcome is possible. Okay. So either you pick a red ball or a blue ball. So 4 plus 0.6 is equal to 1.0. So P, highest value of P is equal to 1.0. Okay. So probability of your sums of all the possible things, it will always be 1. That is also there. Probability cannot be more than 1. If you are doing some calculation and what you are getting is probability is 1.2, then have you done the correct calculation or wrong answer you have got?
Wrong answer.
Wrong answer. Probability cannot be greater than 1. The approach you adopted in the above example is classical. Why? It is calculating a priori probability. See, you didn't do any experiment. You just did mental calculation without investigation or sensory experience. You didn't go and put a pana and then you put 10 balls inside the pana. Then you pick and pick, you pick 10 times and see which one is coming. After that, you decide, so many times, 4 times this is coming. No, you didn't do anything. You just did mental gimmicks, right? Only mental sum you did and you got it. So that is a priori probability. It is so named because it was the first type of probability studied formally by mathematicians in 17th and 18th centuries. That's why. Now let us study empirical probability. Okay, before you go to empirical probability, here is the formula. So far we have been telling the formula, but now they have themselves giving the formula. Number of favorable outcomes divided by total number of outcomes. That is P of E. E is what? What is E? E is not an outcome.
Event.
E is an event. Event is something you define. Human beings should define the event. Probability of getting odd number. Probability of getting even number in the dice. Probability of getting a head. Probability of getting a tail. Probability of picking a heart king or a spade king. Like that. You have to define the event. Okay. Outcome will be decided by chance. You just throw, you pick the card. After that, it is not a spade king. You actually chose a diamond jack came. Okay, that means you do not get the event. This event did not happen. What is an event? Event is defined as, you defined event as probability of picking a spade king. Probability of picking a scale. Outcome, actual outcome happened was Jack Diamond actually came out. Okay, like that. Okay, 5:35 we started, no? So we have 15 more minutes. We can go on. Okay, very good, very good. Oh, this is the formula. Please remember this formula, very important formula. Number of favorable outcomes by number of total number of outcomes. Then now let us take the empirical approach and see what that is. This is a relative frequency theory. It's called relative frequency theory. How many times out of total number of times it occurs? Suppose, okay, an experiment is done 100 times. A random experiment is done 100 times. Okay. Out of that, 20 times an event occurs. 20 of the outcomes are about an event. Okay, then probability is 20 by 100 or 0.2. Okay, so how you do? You do the experiment. You actually do the experiment 100 times. Do the experiment 100 times. That is the empirical. Actually, you do the experiment 100 times. And then you found out that 20 times the outcomes are about your event. Okay. The probability, okay, let us say, take an example and see, then it will be very easier to understand. Empirical approach. A manufacturer produces 10,000 electrical switches every month, and 1,000 of them are found to be defective. Okay, so how many times experiment is done?
10,000.
How many times experiment is done? How many times?
10,000.
10,000 times. Super. So this is the total number, sample space. 10,000 times done. And how many events defective? 1,000 is found to be defective. 1,000 by 10,000 is equal to 1 by 10. Therefore, the probability of the event that it will be a defective electrical switch is 0.1. P is equal to 0.1 or P of E 0.1. That's how you should write. Okay, P of E. What is the event? Getting a defective switch. How did you know this? You didn't do mental calculation and all. Okay, what you did? You actually manufactured 10,000 electrical switches, and then you examined each of the 10,000 switches, and you found out that 1,000 of those switches are defective. All right. You understand what is empirical approach?
Yes, uncle.
Empirical means actually do the experiment on the field and then measure and see. Okay. A priori means before you do anything, mental calculation itself, you calculate the probability in your imagination. Okay. That is the difference. Now let us formalize this definition. If the total number of trials, say n, we find R of the outcomes in an event E, then the probability of event E is denoted by R by n. The total number of trials is n, 10,000 trials. Okay. So n is 10,000. We find R of the outcomes are in the event E. What is the event E? A defective switch. What is the total number of trials? Manufacturing a switch. Each trial is a manufacturing a switch. What is the event? The event is getting a defective switch. Okay. If we find R of the outcomes are in the event E, then the probability of the event E, the probability of getting a defective switch is equal to P of E is equal to R by N. R was 1,000, N was 10,000. So R by N is 1,000 by 10,000. Probability of event. Okay. Now, is there a guarantee this value will settle down to a constant value and the number of trials get larger and larger? They're telling you can't say. This will become more and more accurate. No, we don't know. Because the concept is experimental. It's quite possible to get distinctive relative frequency each time the experiment is repeated. Okay. So you can't say it will get to more and more into a fixed number. We can't say that. But what you can say is that the value of the probability can take the least value 0 and the most value is 1. Okay, mathematically, if you speak, P of E is always less than or equal to 1. That is why that probability was 1.2 man. There is no such thing called 1.2 probability. Okay, that probability is minus 0.4 man day. There is no negative value probability. You understand? This is saying, I'm saying the probability of not occurring. No, not occurring is not negative. That is also positive value. Every probability will be a value between 0 and 1. This is also very important. Okay. P, whatever way you calculate must be between 0 and 1. So I'm telling, hey, probability of rain is 15%. See, this is 15 is greater than 1. No. What you actually told is probability is 0.15. Probability of rain is 0.15. Then you said, no, I said 85%. What you actually said is probability of rain is 0.85. Again, it is, I will tell, definitely it will rain, 100% it will rain. Then what they are saying, probability is equal to, rain is equal to 1.0. That's all. It will definitely not rain. It will never rain, man. Then you are saying probability is 0%. That means P of E is equal to 0. Something will never happen means 0. Something will definitely happen means 1. We don't know whether it will happen means in between 0 and 1. You understand? Very simple. You're understanding, guys? Very simple. Probability is always common sense. So if you have common sense, you will understand and enjoy this very well. So you never got one defective switch also. Then you got R0. Then probability of defective switch is 0. Every switch you manufactured, all the 10,000 switches were defective. Then probability is 1. Probability of getting a defective switch is 1. That means that manufacturing process will certainly produce defective switches. Don't buy from that company because every switch is defective. Never go there. Okay. So from 1, 2, and 3, we find P of E is less than or equal to 1, greater than or equal to 0. Okay. That is the main thing. Okay. Let us explain some more. One example we'll do, we'll get an idea. 2 examples we'll do, and then we can finish. When a dice is rolled, find the probability get the number which is greater than 4. Can somebody tell me how to do that? What is the sample space?
1, 2, 3, 4, 5, 6.
This is a full sample space. What are the favorable events? Favorable outcomes? Favorable outcomes are?
1, uncle.
No, not 1. Greater than 4.
Greater than
What are the numbers greater than 4?
5 and 6.
So favorable outcomes are 5 and 6. What is the n of favorable outcomes?
2.
What is the n of the sample space?
6.
6. So probability of getting more than 4, greater than 4 is equal to 2 by 6. That is equal to 1 by 3 or 0.33. That is what is given here. All right, very easy. Okay, we have to find the number of, you have to first find the set event of all the favorable outcomes, then calculate the number of favorable outcomes. Then you have to calculate the whole sample set. If it is a dice, you already know sample set will be 1, 2, 3, 4, 5, 6. So n of s will always be 6 if it is a dice. Okay, so that is easy. Then divide the n of favorable outcomes by n of sample space. That is 2 by 6 is 1/3, which is 0.33. You can either leave it as 1/3 or you can put it in decimal. No need to always do decimal. Sometimes that will waste your time. We have some more time. Let us do example 9.2 also. In office, with 42 staff members work, 7 staff members use cars. This is a very easy mental sum. Okay. What is the total sample space size? 42. Okay. What is the favorable outcomes for cars? 7. Okay. So n of c by n of s equal to 7 by 42. So the probability of fellows coming by car is 7 by 42. Okay. You divide by 7, you'll get 1/6. Correct? Huh? 1/6. Then 2-wheelers, they come, 20 fellows come. So n of 2-wheelers is 20. N of sample space again is 42. This will be 10 divided by 21. So probability of coming by 2-wheelers is 10 by 21. Is given 10 by 21. Okay. Then same way for cycle, how much? 15 by 42. Number of fellows coming by cycle divided by total number of fellows coming. Okay, 15 by divide by 3, 5 divide by 3, 14, 5 by 14. Then this is also correct. That's all. Okay, you understood that. So this is how you find probability. N of c by n of s, n of t by n of s, and n of cycle by n of s. So both the c are same. Car is then you put n of ca. Here you put n of cy. Like that you put cy for cycle, ca for car. Let me paste this in your WhatsApp. Okay, we'll do just one more example and we'll stop for the day. Okay, now look at this example 7.3. It's very interesting, slightly different example. Team 1, team 2, there are two teams and each are playing 10 cricket matches, 20 over matches they are playing. Okay, their total scores in each match are tabulated as following below. Okay, what is the team 1 and team 2? They are playing 10 matches. Okay, now they are playing against each other probably. What is the relative frequency of team 1 winning? What is the probability of team 1 winning is asking. Okay, now see, n is 10. N of sample space is 10. 10 games they played. In the 10 games they played, you want to find out team 1 winning. Okay, what is the team 1 winning? T1 wins. T1 wins divided by total number of games played. N of sample space. This is 10. Okay, how many it won? Team 1, how many it won? What is score? Team 1, 200, team 2, 143. In this match, who won? Tell me,
Team 1, uncle.
Team 1 won. Okay, next one, 122, 123. Who won?
Team 2.
Team 2.
Here, who won? Team
Team 2.
Team 2.
Here, 4,
Team 2.
5,
Team 2.
Team 2.
6.
Team 1.
Very good. 7,
Team 2.
8,
Team 2.
9,
Team 1.
Team
10.
Team 2.
10.
Okay, how many times team 1 won?
3 times.
3 times. So your answer is 3 by 10, that is 0.3. Okay, that's what is given. Understood? Very simple.
Yes, sir.
Okay, number of the favorable outcomes is 3. Now, this is a experimental empirical approach. What approach is this? Empirical probability. Why? Because they have already
They
played the
actually
matches.
played
They
them.
already played 10 matches, and from that they took the results and started counting the scores and found that this fellow is getting 3 out of 10 only. Therefore, 0.3. Okay. But if you do mental sum without doing actually playing the game, without actually doing the experiment, mentally itself we found out, then that will be classical probability. Okay. Now we finish that exercise 9.1. We will do Wednesday. All right. Very nice. Very easy, guys. Probability is common sense. Once you start enjoying this, you will start using it in your daily life. Very, very much you will become very empowered in your daily life. All right. Shall I stop the thing? Okay. Bye, guys. See you on Wednesday then. Thank you for the fees all of you paid. Bye-bye. See you. Tell
Bye.
your parents also. Bye.
Bye.